Hello everyone, welcome to Simplified Triple Studies. In this session, I am going to discuss the brief idea about transistors and BJT. So BJT is one type of transistor. So first let me discuss the classification of transistor. So there are few questions which can expect from this topic, especially for various competitive examinations such as KSEB AE and SSC JE, etc. So moving on to the discussion. So first of all, we'll understand the importance of transistor. So why transistor is required. So initially, I'll be showing you how the word transistor came up. Actually, transistor is nothing but transfer plus resistor. So these are the two words which are comes under transistor. So the main purpose of transistor is to transfer current or any signal from one resistance path to another resistance path. That's a major purpose of transistor. Usually transistors are used for amplifier and you can go for different type of biasing. Fine. So you can transfer the signal from one point to another point. All right. So the transistor can be broadly classified into two types. The first one is called as bipolar junction transistor, abbreviation is BJT. Another one is called as FET, field effect transistor. When it comes to BJT, there are two classifications. One is NPN transistor, other one is called PNP transistor. If I talk about FET, then there are two types, junction FET, other one is called as metal oxide semiconductor field effect transistor. So these are the classification of transistor. Now let me move on to bipolar junction transistor. So BJT, the elaboration is bipolar junction transistor. It is a current control device. Please make a note. Current control device. Because some questions you may get the direct direct theory type question. BJT is known as dash, current control device, voltage control device, none of this. You need to choose the current control device. Sometimes you may get a question like the MOSFET. MOSFET is dash type of device, current control device, voltage control device, and none of this. The right answer is voltage control device. I request everybody to note down this. Okay, voltage control device. Because I found this kind of questions in some JE-based examination, junior engineers-based examination. Okay, moving on to the discussion. There are two type of BJT, two configurations. One is NPN, other one is called PNP. NPN is most popularly used type BJT because electrons are the majority carrier in case of NPN transistor, and the controlling also will be easy for NPN transistor. So NPN is quite popular compared to PNP type transistor. That is also a very important point. Now I will discuss about NPN transistor. So as you can see, this is your NPN transistor. Look at this. So there are three terminals as we discussed. One is emitter, other one is called the base, then collector. These are the three terminals. So combination like N, P, N. So that is why it is called the NPN transistor. Symbol will be like, we can say that the direction is to away from the emitter terminal. So if you see this kind of symbol, sometimes they may give the symbol, then I'd ask you to identify what is this type of transistor. So check the symbol. If the emitter current is outward, then obviously it is NPN type transistor. Hope it is clear to everybody. So now we'll discuss about the PNP type transistor. Look at this. So as you can see, PNP type transistor is given below. So how you identify PNP? We have P, then NP. So it is PNP type transistor. We have emitter, then collector, base. The direction of emitter current, you can see it is inward direction. See, look at this. Emitter current is inward direction. So explicitly we can say that this is a PNP type transistor. But holes are the majority carrier for PNP type transistor. And so because of that purpose, controlling will be difficult. And PNP transistors are rarely used, very rare. So now we'll discuss about the various three terminals of a transistor, BJT. So we have emitter. So emitter supply the majority charge carrier. The peculiarity of emitter is it is heavily doped. Okay, left-hand region of a transistor, that is called emitter. Okay, so make a note of this. Here, one thing you can these 2 points is very important. See, look at this. These 2 points are very important. So, which is the heavily doped region? You have to select that emitter is the heavily doped region. Okay. Now we'll discuss about which is the region where the lightly doped area is occurred. That is base region. It is very lightly doped. Also the thin region. Base is a thin region. It is the middle portion of the transistor. That is about the base region. You have to understand the fundamentals. Okay, you may get some questions related to fundamentals. Like sometimes they may ask you to pick out the right sentences among 4 or 5 list. Collector. Collector is the right hand region. Also, it is a majority carrier, and the main function is which are coming from the base. It is moderately doped. Dash terminal is moderately doped, medium doped. That is collector terminal. Collector region is made up of physically longer than other region. It dissipate bulk amount of power. High dissipation will be occurring in the collector terminal. The terminal which occurs high power dissipation, you have to select the collector terminal. Moving on to the configuration, 3 types of configurations available: common base, common emitter, common collector. Which is the most popularly used configuration? Obviously, common emitter configuration. Especially if I talk about amplifiers, we are using the common emitter configuration. That is a very important point. Now we'll continue. So we'll discuss individually. You may get some questions from different configuration. Okay. So please note down carefully. Common base configuration. Here base is actually considered as common. Fine. We have the input, like input is applied across emitter base, output is collected across collector base. Therefore, we can write, if you apply KCL, you will get emitter current is the sum of collector current and base current. That is very important equation. If you apply KCL, you will get. So now this equation is very important. Similarly, another one is actually the formula of current gain. So current gain can be written as alpha that is equal to negative of IC divided by I. So why negative sign? Negative sign is due to the different direction. That is why the sign is given as a negative. All right. Ratio of collector current to the base current is known as alpha DC, IC by IE. So one more important thing. If you found the value of alpha DC is very high, it's a ratio. If you found the alpha DC is very high, then it is a better desirable quality of a transistor. Usually the alpha DC that varies from 0.95 to 0.9 for a better quality of transistor. So this kind of numerical example you can expect. So you have to know the formula. 2 formulas you have to know, that I is equal to emitter current is equal to sum of base current and collector current. Similarly, alpha IC divided by IE. Okay, symbol is important, negative. Okay, fine. These points you have to remember. If you know these formulas, you can easily solve these kind of problems. Moving on to common emitter configuration. So here you can see that the emitter is common to base and collector. Okay, so here we have to say another parameter called beta. So beta will be another constant. Maximum value of beta is equal to 500. It's a constant. There is no unit. Okay, it's a unitless quantity because beta is the ratio of the collector current to the base current, IC by IB. So therefore, we can write one more equation. If you already know this formula, IC is equal to IB plus IC. Now IC can be written as IB into beta DC. Therefore, IB will be taken outside. Then by simplifying the equation, IC equal to IB into 1 plus beta DC. There is another relation between alpha and beta. This is very, very important question. Beta is equal to alpha by 1 minus alpha. Most important. Okay, that also you have to remember. Okay. Or otherwise, let us move on to this equation also. Alpha is equal to beta by 1 plus beta. Any equation is fine. From that you can derive. Okay. Beta is equal to alpha by 1 minus alpha. Else, alpha is equal to beta by 1 plus beta. Both are equal. Don't make any confusion regarding this. If I talk about the common collector configuration, okay, common collector configuration, you can say that IC, this part is common. Collector is common to base and emitter. So if you apply this equation, I can make out like output current is equal to 1 plus beta into input current. If I take out the ratio of emitter current, base current, and collector current, I can easily write like 1 minus alpha, and alpha. 1 minus alpha, and alpha. So emitter is to base is to collector is equal to 1 minus alpha, and alpha. Okay, this is very important. Sometimes you may get the question directly. So transistor leakage current is another part. There are 3 types of transistor leakage current: collector to base leakage current, collector to emitter leakage current, emitter to base leakage current. So like ICBO, ICEO, IEBO. So for common base configuration, you can calculate the base current. You can write the base current in this fashion. For common emitter, this is actually the equation for base current by relating the collector to emitter leakage current. Another important phenomenon called thermal runaway. What do you mean by thermal runaway? So thermal runaway, it is one of the temperature dependent phenomena. So as you know that leakage current, due to the leakage current, the temperature is getting increased. So leakage current is almost double for every 6 degrees Celsius for the rise in germanium and for every 10 degrees Celsius rise in silicon. There are two types of semiconductors, silicon and germanium. With respect to the rise in temperature, obviously there is a growth of leakage current. That is why we have to take care about the thermal runaway. What is the impact of thermal runaway? So every time the leakage current will be increased, ICO. As the IC will be very high, what is going to happen? Because of increasing ICO, the collector current is getting increased. As the collector current is getting increased, power dissipation also will be high. Ultimately, it will destruct the property of transistor. So transistor will be getting damaged. So it's a temperature dependent phenomenon. Fine. This is called thermal runaway. So proper heat sink you have to use. Fine. And also you have to control the leakage current. These kind of problems I have seen in some previous year question papers. So you have to use the following equations. Like noting down the data they have given in the question. So use the formula of calculating IC. Once you get the value of IC, you have to use the formula IC equal to IB plus IC. Then you can calculate the emitter current. So another type of question which is already repeated in the year of 2014. So you have to read the question carefully. From this, you have to use this formula. ICS, saturation current is equal to, collector saturation current is equal to the VCC minus VCE saturation by RC. If you solve it properly, you are able to get this particular answer. So operating region, there are three type of operating region for every type of BJT. Cutoff region. Okay, in that emitter based junction and collector based junction both are in reverse bias condition. So saturation both are actually forward bias condition. Where active region, what about active region? Emitter based junction forward biased, collector based junction reverse biased condition. So these conditions you have to remember. So VC is equal to VCC. That is what is identify the condition. It is called cutoff region. So during the saturation region, VC will be absolutely zero. So remember this particular formula. If I talk about active region, always remember that voltage across emitter and collector will be positive. VC greater than zero. So there are three types of important biasing. From that also you can expect some question. Base resistor method, collector to base bias, voltage divider bias. Okay. So base resistor method means you are controlling the base current actually, because transistor BJT is a current control device. You are controlling the current flow through the base with the help of a resistor. So resistor will oppose the movement of current. Therefore, it controls the transistor by using by connecting a resistor a series to the base. So this point you have to remember. And then there is one stability factor equation. So you can note down the stability factor equation. So stability factor of common base configuration, that is equal to 1 plus beta stability factor. Okay. Stability factor should be high. So let us move on to other configuration. Common base configuration, it is a simple one, easy to bias, and there is no loading effect. So main problem is stability is poor. There are production of heat because you are using resistor at the base side. Also, there are chances of thermal runaway because temperature is getting increased. In parallel, ICO will be increased. Okay, leakage current will be increased. As a result, collector current also will be increased. Due to that, high power dissipation. When it comes to collector to base biasing, okay, this is the equation for stability factor. Fine. As the value of collector current increases, voltage across load will be increased. Ultimately, collector to emitter voltage will be getting increased. Third type of biasing is known as voltage divider bias. It uses the potential divider rule. So most convenient one and a prominent one. And voltage drop across R2 is forward biased, the base emitter junction. And this causes the base current and hence the collector current flow to the zero signal condition. Basically, if you look at the circuit diagram, you will understand how it operates. It's just like you are dividing the voltage actually, you can see that. So total voltage is divided by using R1 and R2. Here stability factor will be 1 only. smallest possible value of stability factor leads to the maximum possible thermal runaway. That is another concept. So which is the most convenient biasing. So we can go ahead with the voltage divider biasing. So in this session, what I discussed is the fundamentals of transistor. We discussed about what do you mean by transistor, how the transistors are divided, then what do you mean by stability factor, then thermal runaway, then each configuration, common emitter, common base, common collector we discussed. Apart from that, we have discussed some important formulas, and I have just given the hint how to solve some numerical example based on these formulas. This is actually the basic information about transistor. You can note down the important points. If you solve some numerical example, you will understand more about this topic. So thank you so much for watching this video. Let me know if you are having any questions. Have a happy learning. Thank you.